So welcome back to the videos for the signed numbers unit. This time our topic is subtracting real numbers. And to be quite honest, this is the most difficult concept in integer or real number operations. So please pay careful attention to what you need to do in order to get the right answer. Because if you don't follow the instructions, you probably will think you know the right answer, assume you know the right answer, but not really know the right answer. So let's get started. There's one rule for subtracting real numbers, and that rule is to add the opposite. Now, in order to apply that rule, you have to understand what that means. So essentially, we're not really going to be thinking about subtracting in the sense of looking at the problem, seeing a minus sign, and automatically subtracting. Now, obviously, if it's a problem that you've been doing since you were in primary all the way up through 5th grade, you just would do the big number minus the little number and you'd be finished. But of course, we're going to be using signed numbers in this unit, and so therefore, actually for the rest of your life now, therefore you have to understand that subtraction will change the way you think about doing things with negative numbers. Okay, so when you add the opposite, basically you leave the first number the same, you change subtract to add, and change the second number to its opposite. So let's just look at these examples I put on here. So 3 minus 5. 3 is smaller than 5. So you've been told up till now that you can't do that because 3 is smaller than 5. Well, what we're learning now is that we can do that because we're going to change subtract to add, and you're going to change the number 5, the second number, to its opposite or its additive inverse, which is negative 5. And now you're actually going to do the addition problem that is written right here, and forget about the problem that you started out with. So now you're going to do 3 plus negative 5. So the rule is if the signs are different, you find the difference, which means you're going to do big absolute value minus small absolute value. So 5 minus 3, and then that's 2. And then you take the sign of the number with the bigger absolute value. Negative 5 has the bigger absolute value, so it's negative. Okay, next example, 3 minus negative 5. So you haven't ever subtracted negative numbers before, at least not since until 6th grade. So this technically is a review, but just a reminder. So the first number stays the same, the 3's are the same. The subtract changes to add, and the next number changes to its opposite. So the opposite of negative 5 is 5, and now we forget about the subtraction problem. You do 3 plus 5, that equals 8. We're done. Looking at the next example, negative 3 minus 5. Again, you haven't subtracted with negative numbers before 6th grade. This is now 7th grade for most of you, but that's the idea. So negative 3 minus 5, the negative 3 stays the same. The minus changed to addition. 5 changes to its opposite, negative 5. We forget about the original problem. Kind of scribble that out messily. Now we have negative 3 plus negative 5. To add, you add the absolute value. So 3 plus 5 is 8. And you keep the same sign because the signs are the same. Negative 8. Okay. Finally, we have the exact same numbers. Now, with 3 and 5, same absolute values, but you notice that we have negative 3 minus negative 5. My pointer won't actually go to that exact place. So the negative 3 stays the same. The subtract changes to add. Negative 5 changes to its opposite, positive 5. Now we forget about the subtraction problem that's there. We follow the addition rules. The signs are different. When the signs are different, you take the difference of the absolute value. So you do 5 minus 3. 5 minus 3 is 2. and then you use the sign of the number with the higher absolute value. So we're going to use the. So we find the difference. We get 2, and then we use the sign of the 5 because it's got the higher absolute value, so it's positive 2. So let's move on now to doing some examples. So subtraction with integers. I'm not going to do 100 of each thing this time like I did with the addition, because once you get the idea of changing the problem, it's all good. So let's do negative 11 minus 12. So my guess is that your instinct is that the answer is 1, and is definitely not 1. That's usually what people think. Okay? So if I were doing this problem, I would use the problem as it's written. I'm going to keep the negative 11 the same. I'm going to change subtract to add, so I'm just going to put a plus sign there. Okay? I'm going to change the 12 to its opposite, so that means that I'm going to change 12 to its opposite, which is negative 12. Okay, and now I have the addition problem, negative 11 plus negative 12. So just like I did before, when I have an addition problem now, I ask myself the question, are the signs the same or different? They're same. When they're the same, I'm going to add the absolute value. So I'm going to do 11 plus 12 and keep the signs. So 11 plus 12 is 23. And if I keep the sign, that means I'm going to keep that negative sign that they both have here and here. And so I get negative 23. Okay, there's that. Do one more with just regular integers. So this time we're going to do 3. I shouldn't probably do 3. Let's do 31 minus negative 9. So again, I'm simply going to leave the first number the same. I'm going to change the subtract to add. And then I'm going to change this number to its opposite. So the second number to its opposite. So the opposite of negative 9 is positive 9. So I can just do that right there in the problem. And now I'm going to do 31 plus 9. And 31 plus 9 is a problem you've been doing since you were in 2nd grade probably, or maybe even 1st grade. 31 plus 9 is 40. And that is the end of the problem. Okay, so let's move on to doing a decimal example. So let's do negative 7.2 minus negative 9 minus negative 9. I like that one. Okay, so 1 is a decimal number, 1 is an integer, but that's okay. All right, same rule. It's a subtraction problem. You haven't known how to subtract except in 6th grade, and the rule is leave the first number the same, change subtract to add, change the second number to its opposite. So the opposite of 9 is negative 9 again. Oh, I didn't realize I used the same number. Silly me. That's okay. Okay, so now I'm looking at the problem. I have a negative plus a positive. The signs are different. So when the signs are different, I'm going to find the difference of the absolute values. So the absolute value of this is smaller than the absolute value of that. So I'm going to do 9 minus the absolute value of 7.2, which is 7.2. And of course, I did a good job of lining up my ones place. I have to add in here a decimal point and a 0 so that I can then borrow. 10 minus 2 is 8. Bring down my decimal point. 8 minus 7 is 1. And then I have to make a decision about the sign of my answer. So the rule is, if I'm finding the difference, I take the sign of the The signs are different. I find the difference and take the sign of the number with the higher absolute value. 9 has the higher absolute value. It's positive. So my answer is positive 1.8. And you don't need to put that plus sign in there because it's invisible. Alrighty. So let's do one with rational numbers and then one with absolute value. Okay. So my example is going to be 28 28 and 1/3 minus 48. Okay, so this doesn't look weird because there are no negative numbers involved, except that the smaller number is before the bigger number. So when the smaller number is before the bigger number, we have always been told we couldn't do that. Now we know that all we need to do is to change subtract to add. Leave the first number the same, change subtract to add, and change the second number to its opposite. So 48 is now negative 48. Now we're going to do the addition problem. The addition problem has two numbers with different signs. So we find the difference after taking the absolute values. So if I take the absolute value of that and I take the absolute value of that, 48 is bigger. So 48 minus 28 and 1/3. So I have to borrow here because I don't have a fraction from which to subtract. So I'm going to borrow 1 from 48, making it 47. I'm borrowing 1 whole, so I'm going to borrow 3/3. And that gives me 21 and 2/3. And then the number with the bigger sign is the bigger absolute value is negative 48, so my answer is negative 21 and 2/3. So one last little thing I want to talk about is this absolute idea of absolute value. Remember in the unit R, the lesson on absolute value, I told you that you take the absolute value before you do you do the problem inside the absolute value signs excuse me, before you find the absolute value. So let's say we have negative 3 minus 9. We'll just do one that's easy to figure out in our mentally. Okay, so negative 3 minus 9. You didn't do subtracting with negatives before. We're supposed to find the absolute value at the end of the problem. So the first thing we have to do is what's inside there. So we have to do the subtraction problem that's indicated. So we have to do negative 3, which stays the same, change subtract to add, change 9 to its opposite, which is negative 9, and then we're going to do the problem that's inside the absolute value signs. So you do negative 3 plus negative 9. The signs are the same. You add their absolute values, so we're going to do 3 plus 9, which is 12. Keep the same sign, so negative 3 plus negative 9 is going to be negative 12. And I still have those absolute value signs there because I take the absolute value at the end of the problem. So now that I have a number inside of there, all I have to do is take the absolute value, and the absolute value of negative 12 is positive 12. Okay? If I had the absolute value of 1 minus 9, or 11 minus 9, let's get rid of that example. That's a bad example. It doesn't matter. For the rest of these, all you have to do is just do the problem that's inside the absolute value signs first before you subtract. Okay? Good luck with that.